Welcome to This Explainer. Today, we're diving headfirst into the massive scale, the fascinating history, and honestly, the incredibly fragile future of our planet's waters. You know, we look at globes and mostly just see this giant expanse of blue. But today, we're going to peel back the layers and uncover the structural, historical, and chemical secrets that are hiding in plain sight right within that blue space.
So, let's kick things off with a number we all know, 71%. That is how much of Earth's surface is covered by water. It's exactly why we call our home the blue planet. But here is a question for you. Geographically speaking, what is the actual structural difference between an ocean and a sea? We tend to toss those words around completely interchangeably in casual conversation, but in reality, they represent entirely different geographic and ecological systems.
Okay, let's break this down. Oceans, they are the absolute heavyweights. We're talking massive, continuous bodies of open water with no true physical boundaries other than the continents themselves. And they plunge to just mind-boggling depths like 11,000 meters down in the Mariana Trench. Seas, on the other hand, are kind of like the ocean's quirky little cousins. They're much smaller, way shallower, and the key thing here is that they're partially enclosed by land masses. Think of them as the ecological front doors to our continents. They give the land a really distinct biological identity compared to the freezing, crushing depths of the open ocean. Now, when you stack up our 5 global oceans, the drop-off in scale is honestly wild. The Pacific is just a monster, an absolute titan covering 180 million square kilometers. I mean, it completely dwarfs the Atlantic at 106 million and the Indian Ocean at 74 million. And by the time we get to the icy extremes of the planet, things shrink pretty dramatically. The Antarctic sits at 22 million, and the relatively shallow Arctic Ocean is just a tiny fraction of the Pacific's size at 14 million square kilometers. It really puts into perspective just how much the Pacific Basin dominates the globe. But there's this really funny historical irony hiding in the name of that massive ocean. I mean, it covers a third of the entire Earth's surface. You'd completely expect a name that screams dominance, relentless power, something intimidating, right? But the word Pacific literally means peaceful, tranquil, calm. It feels like a massive misnomer for such a beast of a geographical feature.
And for that, we can totally blame Portuguese explorer Ferdinand Magellan. Back in 1520, he happened to sail into some incredibly calm waters during his Pacific voyage, and he just went ahead and named the whole ocean after that one localized experience. Talk about an inaccurate first impression. The Pacific is actually anything but tranquil. It sits right squarely on top of the Ring of Fire. That means its waters are constantly getting rocked by violent volcanic eruptions, deep-sea earthquakes, and massive tsunamis. It's arguably the most dangerous, geologically active body of water on Earth.
Okay, let's pivot from the giant oceans over to the seas. You've definitely heard the super romanticized phrase, sailing the 7 seas, right? It immediately makes you think of these swashbuckling globetrotters charting the entire world. But historically, it wasn't a global concept at all. Long before we had the real scale of the Earth and its 5 oceans mapped out, the whole 7 seas thing was just a very localized, ancient geographical concept.
Yeah, if you look at ancient and medieval texts, like the famous tales from 1001 Nights, the 7 seas were really just a list of vital trade routes. The scope was incredibly focused. We're talking about the Adriatic, the Arabian, the Caspian, the Mediterranean, the Black and the Red Seas, plus the Persian Gulf. For early civilizations, successfully navigating that specific little cluster of trade routes practically meant you had conquered the entire known world.
Fast forward to today, and oceanographers actually recognize over 60 different seas globally, up to 80 if you count all the subdivisions. But here is the cool part. Despite all that massive variety in size and climate, nature organizes every single one of them into just 3 distinct categories. And it's all based entirely on one simple geographic rule: how they shake hands with the open ocean.
First up, we have the open, or coastal seas. Think of these guys as the extroverts of the marine world. They have these massive, wide-open borders directly shared with the ocean. A perfect example is the Caribbean Sea. It's sprawling, covering over 2.8 million square kilometers, and it just freely, constantly exchanges its waters, its nutrients, and its marine life with the Atlantic Ocean across this huge, unrestricted boundary. Next, we've got inland or continental seas. Now these are way more restricted. They have a kind of secretive relationship with the ocean, only connecting through these tiny, incredibly strategic portals called straits. It's actually amazing to think about.
I mean, take the Mediterranean Sea, this massive body of water steeped in human history, and it relies entirely on a single choke point to get to the Atlantic, the Strait of Gibraltar. It squeezes all of its oceanic water exchange through a passage just 14.4 kilometers wide.
What's truly fascinating, though, is how some of these inland seas are literally named after their bizarre chemistry. Take the Red Sea, for example. It actually gets this dynamic reddish tint from iron or dust blowing off the desert mountains, mixed with these massive seasonal blooms of red algae. Then contrast that with the Black Sea. Its depths harbor this massive concentration of hydrogen sulfide, creating a dark, muddy, almost alien layer that is completely uninhabitable for marine life. Well, outside of some highly specialized bacteria anyway.
And that brings us to the ultimate introverts of our blue planet, closed or isolated seas. Just like the name implies, these have absolutely zero connection to the global oceans today. They are essentially giant, completely landlocked saltwater lakes, but because of their immense size and that salty chemistry, which is actually a leftover evolutionary trait from millions of years ago when tectonic plates shifted and trapped the water, we still classify them as seas.
The extremes inside this closed category are striking. The Caspian Sea is just a geographic marvel. It holds the title for both the world's largest lake and the largest closed sea, dominating over 371,000 square kilometers. But on the exact opposite end of the spectrum is the Aral Sea. And man, this is a tragic story. It used to be a massively thriving hub of water, but aggressive agricultural diversion basically bled it dry. In just a few decades, it went from one of the largest inland bodies of water on Earth to a sprawling, toxic desert wasteland. It is literally one of the most devastating ecological disasters in modern history. That delicate balance leads us perfectly to perhaps the weirdest geographic anomaly of all, the Dead Sea. Stuck right on the border between Israel and Jordan, it sits in a massive depression about 400 meters below standard sea level. That makes its shores the absolute lowest point on the Earth's surface. And because it's baking right under an intense desert sun, the whole area acts like a giant geological evaporation pan. The water turns to vapor incredibly fast, leaving all the heavy minerals trapped behind in the shrinking basin. The result of that unending evaporation is just extreme. To put it in perspective, your average ocean water hovers around 35 grams of salt per liter. The Dead Sea? Try 300 grams. It's almost 10 times saltier than the ocean. That intense density makes the water so incredibly thick that fish simply cannot survive, hence the name dead. But it creates this surreal physical phenomenon where you can hop in and become as buoyant as a cork, just effortlessly floating on the surface. But here's the reality check. Whether we're talking about the freezing, abyssal depths of the Pacific Ocean or the shrinking, hyper-salty waters of the Dead Sea, every single one of these ecosystems shares a really grim commonality today. They are facing severe, unprecedented threats. Global warming is melting ancient glaciers and hiking up sea levels. Massive amounts of pollution are creating literal, sprawling islands of trash out in the open ocean. And shifting climates, paired with our own human intervention, are accelerating the desertification of those ancient inland seas.
Every single drop of this water is absolutely crucial to the climatic balance and biological diversity of the Earth. So, I want to leave you with this vital question to ponder. As we continue to alter the delicate, ancient balance of these waters, what is the map of our blue planet actually going to look like for the next generation?